So in this problem, we have three charges located at different points. They were given the coordinates. We need to find what is the magnitude and direction of the electric dipole moment. So we know the general definition, right? So P is equal to Q1 R1, Q2 R2, Q3 R3. In general, summation over I1 to N Qi Ri. So this is the very important definition of electric dipole moment. So now we have a so I think all the cases Z is equal to 0, we can take it. This is the X, this is the Y. Now the first charge plus Q will be at exactly A distance. This is the plus Q. And minus Q is located X is equal to 0, Y is equal to 0. So this will be the origin. This is a minus Q. And X is equal to A and Y is over here again. At this point, we have another plus Q. So what is the? So now we have only three charges. So we take only three terms. What is R1? R1 is the position vector of the charge plus Q, which is located at, so it will be A into J cap because it is in the Y direction. R2 is 0 because this second charge located at origin, so R2 is equal to 0. R3 is equal to A I cap. So substitute straightforward. P is equal to P vector is equal to Q into A J cap Q A I cap. So the direction of, remember, so I have a Q A I cap plus J cap. This is the electric dipole moment vector. In fact, it is I plus J, definitely exactly it is the 45 degree with respect to either vertical axis or horizontal. So this is the direction of the dipole moment. And what is the magnitude? So square root of QA the whole square, QA the individual component, so root 2 QA. So this is the magnitude. And direction is along the bisector of these x axis and y axis, exactly 45 degree angle.